Hello class, this is a video tutorial on the exponential graph. In the previous video we saw how a small change in the positive x direction causes a rapid change in the y values, and that towards the negative x values the y values become smaller and smaller but never become zero, or they never touch the asymptote. And we also learned how the y-intercept is when x is equal to 0, and when we substitute the value into the equation 2 to the power of x, so 2 to the power of 0 becomes 1. So in this video we're going to look at what happens when we change the values of the base and the constant. So pretty much all exponential graphs follow the form of y equals a to the power of x plus k, where a is known as the base, the x is the index or the indice, and k is the constant. So what I've done here is I've overlaid in green the different changes that you'll see when we alter the values of a and k. Let's first focus on the values of a, the value of the base. So I want you to focus here and also take a look at the behavior that happened to the green line in comparison to the red line. You'll see what I mean in a moment. Okay, so here we go. I'm going to move this up. There, I've moved it to now, it's 2.1 to the power of x. As you can see, it's got a steeper curve now. But if you take a look, the y-intercept remains the same, and the asymptote remains the same. Let's move it again. There we go. So as you can see, the higher the base is, the steeper the curve is compared to what it was originally. There it is, 2.4. 2.5, 2.6, 2.7x, 2.8 to the power of x, 2.9 to the power of x, and 2.10, 3 to the power of x. As you can see, there's a drastic change. It's become much steeper than it was originally. If you take a look, when x is equal to 1, the value of the y is equal to the base. So let's follow the red curve, because the red curve is 2 to the power of x. So when 2 to the power of 1 is equal to, the y value is equal to 2. The green line, however, 3 to the power of 1 is 3. And I'm pretty sure you expect if I move this up to 4, take a look. 4 to the power of 1 is 4. But also, since the base is now 4, the steepness of the exponential curve is much more prominent. If I make a, the base, even higher, it gets steeper and steeper and steeper. There it is. So you can see how much of a change it makes. I'll move it again from 2 to the power of x to 3 to the power of x, 4 to the power of x, 5 power of x, 6, 7, 8, 9, and 10. And you'd imagine that the higher the value of a becomes, the higher the value of the base, the y value becomes greater and greater, becomes steeper and steeper. Let's take a look now at what happens when we increase and change the value of k, the constant. So now, let's move along here. Take note this time of the asymptote and the y-intercept. And also, you can also see this drastic change when we move the k value, the constant value, up and down. Here we go. K is now going to be 1. As you can see, the asymptote, which originally was y equals 0, is now y equals 1. Look at that pattern. So when the constant is 1, the asymptote is 1. And also take a look at the y-intercept. When the asymptote is 1, the y-intercept is 2. Let's move it again. The constant is now 2. The asymptote is now 2. And the y-intercept is now 3. If you see that pattern there, constant is 3, asymptote is 3, the y-intercept is 4. One last time. When it's 4, asymptote is 4, y-intercept is 1 greater, it's 5. When the y-intercept is 5, asymptote is 5, y-intercept is 6. And you can see how it changes. It just moves the entire shape, so it remains exactly the same, but it's just moving the entire thing up and down like a platform. It's being raised. You saw a little glimpse of what happens when it goes into the negative region, but you'd expect that when you move everything up and you change the base, all it does is just, it becomes steeper and it's raised up. So take a look again. So there's 2 to the power of x plus 2. Now if you move it and make it 3 to the power of x, it's still raised up by 2, but now the curve is much steeper. Let's move it back again to the original. Now let's see what happens when we move it into the negative region. So the constant, instead of plus k, it'll be minus 1. So take a look there. I'll move it out of the way. I'll just move it down just a little bit so you can see. So when k is negative 2, so 2 to the power of x minus 2, the asymptote is minus 2, but the y-intercept is negative 1. It still follows that pattern that the y-intercept is always 1 greater than the asymptote. So meaning, when k is negative 3, asymptote is negative 3, but the y-intercept would be 1 greater, so negative 3 plus 1 is negative 2. And I hope that gives an insight into the behavior of the exponential curve or the graph as we change the base and we change the constant. Let's move everything back now. I'll leave it like this so you can see the difference. Oops. Let's move everything back. There we go. So I hope that gave you an insight into the exponential curve and how it behaves as we change the base and we change the constant. Best of luck.